everybody? I hope everybody's doing great. Let's talk about the volume. Remember, this is just a recap of what we did on Monday. Hi, Asbonge. So remember, the volume of any shape is going to be the area of the base multiplied by the height for at least any prism that we know of, right? So I'm going to ask this question. What is my base shape? What is the base shape that I have in this question over here? Who's got an answer for me? What is the base shape? Correct, Pascal. Correct. And I see some people are still joining as we speak. It is the triangle, right? So if we're going to calculate for the area of our base shape, it's going to be our triangle over here. We can calculate for the volume. So volume is going to be the area of a triangle, which is a half base multiplied by the perpendicular height of my triangle multiplied by the height of the prism itself. So if I want to calculate for the volume here, volume is equal to half multiplied by 1.5 multiplied by 2 multiplied by 10. Okay. And if I put this into a calculator, I'm going to get 15 meters cubed. The volume is equal to 15 meters cubed. All right, and that's that question. When we talk about, oh yes, I will answer them in just a second, Anna. Okay, let's just get everybody started. All right, when we talk about pyramids, there are certain formulae that we just need to know. Okay, we can't say that we can figure it out like when we're looking at a prism, like a rectangular prism or a triangular prism, and then we have to figure out what is what. No, our base is always going to be the shape that's holding the thing up. The apex is going to be the other side of our shape. All right. So I'm going to ask you guys to take a quick screenshot of this. You've all got 5 seconds because we are then going to use these to answer for the next part. Now, this part, when we do the volume of prisms, is going to go, pyramids, is going to go very quickly because we're not really doing a lot. We are plugging in the answers on our calculator, like the numbers on our calculator, and we're spitting out an answer. So there's nothing really too mathematical around it. There are ways that we can make it mathematical, like when we look at things like frustums, but I found out the other day that frustums are a grade 11 concept, and we don't have to do them. All right. So Teacher Now's just out here vibing with everybody in the chat. I see you. All right, let's get started on this first one. All right, so remember, the volume of our shape is going to be the area of the base multiplied by the perpendicular height. What is the base shape? What base shape are we seeing over here? Hi, Asi, no problem. It's great to have you with us. What is our base shape over here, guys? Correct, Mahlatsi. Hello, Mahlatsi. It's a square. Yes, Asbongi. For pyramids, it's going to be very obvious what our base shape is. It's going to be the shape at the very bottom of the thing, and then the other side is going to be the apex. So nothing really difficult here, right? And we know that the area of a square, is just side squared. Okay, it's just side squared. No worries, Cassidy, welcome. It's great to have you with us. Jump straight into this question that we've got here. All right, so this isn't going to take anybody too long. Just pop your answer in the chat when you guys are ready. Okay. Oh, sorry. Oh, Teacher Nels, how? You're watching me here. Volume equals a third of the area times.
I was not really watching.
No.
I was answering Anna's questions. Sorry.
I know the chat. Sorry, my brain just, guys, a third of the area of the base times the height. Okay. Right, pop your answer in the chat when you guys are ready. We're not gonna do emojis for this one because this is quite easy. I think everybody's gonna be okay getting this one. 17.4, Asi. Asbonge, it's 17.4. Fingers crossed. I think you're going to do great either way, but still, good luck. I know you're going to do great. Jenna, you wrote maths today. How did it go? I'll tell you something, Jenna. I also wrote an exam today. I wrote an exam this morning. I'll tell you how it goes. I'll tell you how my exam went if you tell me how your exam went. I love it. Love to hear it. She's like, I felt like Einstein. Yeah, I like that. Yeah, I think mine also went about the same. Yeah, I'll tell you what. So I complain all the time about my exams, especially the ones that are about teaching. So whenever I write about teaching, I get really good marks. The maths, sometimes, okay, because it's like higher grade maths, but I'm done with that. So when it comes to the teaching modules, I do really, really well. So one of the English teachers said to me today, are you those kind of people who complain about getting low marks for the exams and then you end up with a 95%? And I was like, no.
Yeah.
Teacher now.
You are, friend.
Oh.
I feel like in high school you'd be like, oh, I did so bad. Oh my God, I thought I was gonna get good marks. And like, what did you get? I got like 75. And I'm like, what do you mean?
But I mean 75-ish. 75-ish.
See?
Teacher Nels, you know what, guys, let's focus. Come on now. All right, if I want to calculate for the volume of the sheep, I'm going to say the volume is 1/3 of open brackets. Now this is 12.9, so 12,9 all squared. That's my the area of my square multiplied by my perpendicular height, which is 17.4. Okay. And Imelda says she got 1,447.8. Did everybody else get the same answer? Something seems a little bit off about that answer, but I will check it now. Times 17.4. Yeah. Imelda, check again. Check again for me, please. Because the answer I'm getting is 965.18 centimeters cubed. Okay, give me a thumbs up in the chat if your answer looks similar to mine. Give me a thumbs up in the chat if your answer looks similar to mine, but okay, we're going to keep moving. All right. Pay attention to the base shape in this one. Again, we're going to use the volume of a pyramid is a third of the area of the base multiplied by the height. Thank you, Lukanyi. So we should be all be getting around that same answer. Okay, I'm going to give you guys 3 minutes to answer this one. Remember that the area of a triangle is half base multiplied by height. And why did I put squared? Do you mean, Asbonge, do you mean over here? Over here. Hello, close bracket. Okay, it's because I'm calculating for the area of a square. Okay, Asbonge, remember that the area of a square is just side times side, which is the same as side squared. Side times side, side squared. So I'm taking the side and I'm just squaring it. Okay, so you're going to get the same answer regardless. Few more minutes. Shouldn't take us too long to get through this. Okay, cool. One more minute. All right, guys, that's time. Okay, let's have a look at our answer over here. So I know that the volume of this shape is going to be a third of the area of my triangle is going to be a half of my base, which is 15, multiplied by the perpendicular height of my triangle, which is also 15, multiplied by the perpendicular height of my pyramid, which is 20. Can somebody pop the answer in the chat for me, please? What did we get? Jenna says 750. And I agree with you, Jenna. Thank you very much. Yes, the answer that we're looking for. Thank you, Imelda and Chloe as well. Beautiful. 750 meters cubed. All right. Here's your next challenge. Okay. So again, remember, volume is a third of the area of the base multiplied by the perpendicular height of our pyramid. We are missing something very important. What are we missing? Any idea? Who can tell? What are we missing here?
Radius.
Correct. I heard somebody unmute and say radius. Yes, correct. We're missing the radius. How are we going to calculate for the radius here, peeps? Oh, Jenna, I didn't even finish my sentence. You must wait for me to finish my sentence. Yes, well done. Well done, Jenna. Yes, we're going to use Pythagoras. Okay, we're not going to divide, we're going to look for the short side using Pythagoras. Okay, so please, by all means, you guys have 3 minutes. No, yeah, 3 minutes is fine. It's not that deep. Okay, you've got 3 minutes, and then we're going to look at this answer, and then we're going to move on to some composite shapes, to the volume of some confiscate shapes, because my English is running away from me. I know, Joe, I'm not doing great. Hey, my English airtime is finished. It's finished for today. All right, pop your favorite emoji in the chat when you're done, peeps. It's not Englishish. Yes, correct. Mashatse, don't give them the answer. They must find it themselves. But thank you, Mashatse. Thank you. Yeah, I'm seeing it. I'm seeing it. It's okay. It's okay. It happens. It's okay. See, guys, when class monitor Jasmine is on the job, guys, watch yourselves. She's watching you. Sure, I'm happy to. I'm happy to. Okay. So, Lukaniso, just if you want to raise your hand so I can unmute you and we can talk, I'm happy to do that. But if not, then just answer me in the chat. Okay. All right. So we know that our base shape is the triangle. That's our base shape over there, right? So when we calculate for the volume, sure, I'm sorry, Pascal, we're just calculating for the volume of this cone down here. Okay, right. So if we calculate for the area of our base shape, remember the volume, Lukaniso, is 1/3 of the area of the base shape multiplied by the perpendicular height, right? So we're then going to calculate, let's calculate for the area of the base. I know that the area of a triangle is half of the base, which is 15, multiplied by the perpendicular height of my triangle, which is 15. So half of 15 times 15. I'm just going to take this area of my triangle and I'm going to insert it here, right? So I'm then going to have volume is equal to 1/3 multiplied by all of that. 1/2 of the base times the height of my triangle multiplied by my perpendicular height, which is 20 meters. So 20 meters. Okay, and then you just punch that into your calculator and the answer you would get out is 750. All right, that's time. That's time, Funzo, you are very correct. Okay, Pascal, we are calculating for the volume of this cone over here. Now, we are first going to look for the radius, which is that part over there. That's what we need in order to calculate for the area, because the area of my circle needs my radius. I know that area is equal to pi times radius squared. So radius squared is going to equal to 17 squared minus 15 squared, brackets, Pythag. We need to observe protocol. There we go. All right, so we must put the Pythag there. We know that r squared is equal to, if you punch that into a calculator, it's like 289 minus 225, it's going to give you 64. The radius is therefore going to be 8. So the square root, correct, close bracket, well done. Our radius is 8. Now, if we're calculating for the volume, we'll say volume is equal to 1/3 of the area of my circle, and I know that the area of a circle is pi, times radius, which is 8, all squared, close brackets, multiplied by the perpendicular height of my circle, of my cone, which is 15. Pop your answers in the chat for me, please, guys. What do we get? Correct to 2 decimal places, please. Beautiful. Oh, Jenna, you are just on point today. I think it's all that good energy from writing a really good test. I see it. Well done. 1005.31 centimeters cubed. Beautifully done. All right. This is as hard as it's going to get when we are looking at pyramids, guys. So give me a thumbs up if you guys are okay with this section. Are we all good here? Beautiful, excellent. I didn't think it would be too difficult. We're literally just taking the formula, plugging it in. Nothing fancy, nothing funky. All right, well done, peeps. Okay, let's talk about some unsavory shapes. Here's your next challenge, peeps. Okay, now, I want you guys to note in this particular question that they are telling us that they want us to find the volume of the composite figure here in terms of pi. Okay, now what this means is when we get to the end of our answer, our calculator normally gives us the answer with pi in it. And then we click SD, we click the SD button. So to decimal, right? We click that button. In this case, they don't want you to click that button. They want you to give them an answer that has pi in it. Okay, so your answer must come as something, something, pi. And for this particular question, I'm going to give you both to do. When you are done with both, then you can pop your favorite emoji in the chat. Okay, take it away, peeps. I'm going to give you guys 2 more minutes, and then we're going to start looking at the answers here. Sure, Chloe and Samuel, you guys are like, All right, peeps, let's have a look at some of these answers. Okay. So I know that this shape is made up of two things, right? The first thing that I have here at the bottom is a cylinder. And I know that the volume of a cylinder is just the area of the base multiplied by the perpendicular height. And I'm going to add that together with the volume of a cone, which is going to be a half of the area of my base. A third of the area of my base multiplied by the perpendicular height. So we need to account for all of that. Okay. Give me 1 second. All right, so the volume of my base is going to be pi times, now please be very careful, guys. My radius is not 6, my radius is 3, because 6 is my diameter. So I need to take pi times 3 squared multiplied by 8 plus a third of, again, pi times 3 squared multiplied by the perpendicular height of my cone, which is 9. And that should give me 99 pi. Remember, do not click SD. Don't click SD. Give your answer in terms of pi. So make sure that your answer has pi in it. All right, and that's the answer I'm looking for. Okay, on this side over here, my base is a rectangular prism, or actually it's a square-based prism, but rectangular, it's fine. Okay, so I know that the area, not the area, the volume. The volume of my base at the bottom is going to be length times breadth times height, length times breadth times height, plus a third of, now here comes the kicker. I'm missing something. A third of half of my base from here to there, which is 6, right? A third of 6. No, what is my area? I'm lying. My area is 12 times 12 again. Okay, lying. A third of side squared multiplied by the perpendicular height h. Now, we don't have h, but we know that I've got a right angled triangle over here, so I need to use Pythag to find that h. Now, this side over here is equal to 10. I know that the apex of my pyramid is going to be half of my square, which means my base over here is going to equal to half of 12. So my base is 6 centimeters. And then I can use Pythag to find h. I will go h squared is equal to 10 squared minus 6 squared, which is going to equal to 100 minus 36, which is 64. Therefore, h is equal to 8. No, sorry, Asi, it's s squared. Sorry, because the bottom is a square, I've just said side squared, not 5. Sorry. Whew, my handwriting today. You're not the first person to complain, Asi, trust me. Okay, so let's talk about the volume. The volume is going to be 12 times 12 times 5 plus a third multiplied by 12 all squared multiplied by 8. Pop your answer in the chat if you do have one for me. Anybody got an answer for me? I want to see if everybody's answer looks like mine. Oh, we should not be getting a fraction. We shouldn't be getting a fraction. Yeah, Funzo, that one I agree with. Correct. Yes, Rulani, that's it. Good, Jenna. Excellent, Cassidy. Good, good, Imelda. Go, just double check for me, my sweetie, what you've done. I don't want to leave you behind. Jenna, not squared. Remember, it is a volume. So we must 1104 centimeters cubed. We must cube it. All right. Okay. I just want to check with you guys. Give me a thumbs up if you're okay with how to calculate for the area of a, I'm saying area, the volume of pyramids. Give me a thumbs up if you're all cool. Excellent. Okay. I mean, it's simple enough. You just take the formula, you plug the thing in, and we keep it moving. Okay. So it's not really that difficult. And I know you guys are like top tier. So I know you guys got this. All right. Okay. Let's look at scale factor. Right. So I've got a tiny little, well, not a tiny little one. I've got a small rectangle. And outside of my small rectangle, I have a big one. Right. Now, if the dimensions of my small rectangle are 7 centimeters by 5 centimeters, what is my area of my small rectangle going to be? What is the area of my small rectangle? 35, good, offense, excellent, it's 35, right, good, 35 centimeters squared. Now, that squared over there is very important, guys. That is the focus of this entire lesson, right? Now, let's say I take these values and I double them. So to go from small rectangle to big rectangle, I take this and I multiply it by 2. What is the area of my big rectangle going to be then? What is the area of my big rectangle going to be? Okay, I'm getting like conflicting answers, but most of you are saying 140. And I, for those of you who are saying 140, I want you guys to explain to me why we say 140. Okay, because technically 35 times 2 should give us 70 and not 140. But trust me, you are 100% correct, Jenna. Yes, 100% correct. The answer is 140 centimeters squared. Okay, if we say 70, we're going to go 35 times 2, it's 70 centimeters squared. But for those of you who are saying 140, why do we say 140? Kellen says we enlarged the shape. What does that actually mean? Let's be honest. Because the logical idea would be to make each of the sides or to just double the idea. Correct. But Asbonge, you are on point. That is correct. Yes, Rulani. We are not doubling the area. The area is not the thing that we are doubling. What we are doubling is the sides. Okay, so each of the sides will have a 2 multiplied to it. So if I double 7, I'm going to get 14 centimeters. And if I double 5, I'm going to get 10 centimeters. And now I know that 14 times 10 will give me 140 centimeters. But if we do it the way that Asbonge has written it over here, which is so smart, the area that I actually have was 7 times 5. But now what I've done is I've gone 7 times 2 times 5 times 2. And that is why we are doubling and then doubling again. Okay, so basically what we've done here, guys, is we've added a factor of not times 2. We haven't added a factor of times 2. We've added in a factor of times 2 squared because it's times 2 times 2. So when we calculate for the area, we would calculate 4 times 2, or when we double the area, we would double 2 squared. What about the volume? If I had to calculate the volume of something and the volume was 35 centimeters cubed, if I doubled the volume, what would I have to multiply this number by to get the new volume? Okay, not just by 3. Of course, I'm going to multiply by 3, but because it's the volume, it would have to be 3 what? Oh, sorry. I'm doubling. Why am I lying? I'm doubling. I'm multiplying by 2, but by 2 what? Correct. Jenna, you're on point. Yes, so 2 cubed. I see you guys writing 3. So in my mind, I just assumed you guys meant times 3. No, not times 3, times 2 cubed. Okay, give me a thumbs up if this makes sense to you. Okay, if it doesn't make sense, please give me a thumbs down. I'm happy to explain again, right? Because the thing we're going to do right after this is going to be a little mind-blowy. So I need you guys to make sure that you're with me when it comes to these questions. Okay, all right, Cassidy and Funzo, where have I lost you? Okay, so Rulani, let's think about this. If I have, what was I doing here? This is long ago things. Okay, all of these things, they need to go, they got to go. All of them got to go. Okay, no problem. All right, so remember guys, if I've got a rectangle, right? And my rectangle is 6 by 4 meters. My area is going to equal 24 meters squared, right? Now, if I multiply the side by 2 and I multiply the side by 2, I've added 2, or I've multiplied by 2 the side and by 2 the side. So in order to find twice the area, I'm going to need to times this by 2 and then times it by 2 again for both sides. Okay. Now, if we take a 3D shape, let's think about this. If I take a 3D shape, and this side is 4, this side is 6, this side is 2. I know that the volume of my shape is going to be 4 times 6 times 2, which is 48 centimeters cubed, right? Now, if I double each of these sides, I'm going to go times 2, times 2, times 2. So if I want 2 times my volume, I have to take this 48 times 2 times 2 times 2. I have to do it 3 times. Okay, not only once, offense. We have to do it all 3 times because all 3 sides are being doubled. Okay, so instead of writing 2 times 2, I'm just going to rewrite this as times 2 squared. Times 2 squared. And I know I have to do this because my units are squared. Same with down here. Instead of writing times 2 times 2 times 2, I'm going to write times 2 cubed. And I know that because my centimeters are cubed. Okay, for those of you who are a little bit lost, can I get a thumbs up if you guys are with me? Excellent, go. Okay, we got it. Excellent. All right, here's our challenge, peeps. Those first 2 questions over there. Go for it. Right, when you're done, just pop your favorite emoji in the chat. I'm just gonna excuse myself for just Okay. I don't particularly think that would take us that long, right? Because we're just looking at the scale factor and then using that to calculate for each of those. All right. So it says for question A here, the surface area of a solid is 26 centimeters squared. Determine the surface area of the solid if it is enlarged by a scale factor of 3. So we know that the area, let me rewrite that again. The area is 26 centimeters squared. Now, they've increased each side by a scale factor of 3. So I know that I'm multiplying by 3 to get the area, but because the area or each side is being enlarged by a scale factor of 3, it needs to be multiplied by 3 squared. Okay, so my new answer is going to be 234 centimeters squared. Right, that's A. Well done, Chloe, that's it. Correct. Now, let's look at B. B says the volume of a solid is 34 centimeters cubed. Determine the volume of the solid if it is enlarged by a scale factor of 4. And I shouldn't teach you guys to just leave that 3 over there. We need to square it as well. Okay, so we know that our scale factor is multiplied by 4, but because it's cubed, I need to multiply by 4 cubed. Right, so my answer should be 34 times 4 cubed, which is going to give me 2,176 centimeters cubed. That's the answer we're looking for. I need to cube this side as well. All right, give me a thumbs up if scale factor makes perfect sense to you. Are we all good here? Sorry. 4 cubed. Okay, beautiful. It's that simple, guys. Now, however, we need to just recognize something as we're going along, because these are the next 2 questions, right? When we are calculating for these 2 things, what we've actually created is, if I create a small rectangle, and then I take the same rectangle and I enlarge it by a scale factor of 2, right? What kind of shapes have I actually created here? What do we call these shapes? Shapes that look exactly the same, but different sizes. Who remembers? We do a lot of triangles with these in grade 9 and 10. Anybody remember? It starts with an S. Yes, Sandakahle. Yes, that's it. Correct. What we've actually created are similar shapes. That's what we've done. We've created similar shapes. Okay, so when we enlarge and when we shrink, it's a similar shape. Now, what do we know about each of the sides? If this side is 4 and this side is 4 and this side is 6 and this side is 6, over here I'm going to get 8, 8, 12, 12. What do we know about the sides of any similar shape? They are what? Correct. They are in ratio or they are in proportion. That's it, Rulani. They are in proportion, right? So I can actually write these in proportion. I can say that 4 over 8 is exactly the same as 6 over 12. And I'm going to get the same scale factor on both sides, right? Now, look at these 2 questions up here. It says here, the surface area of a solid is 45 centimeters squared, and the surface area of its enlargement is 720 centimeters squared. Determine the scale factor by which the solid is enlarged. So how are we going to figure that out, guys? We already know that they are similar shapes. So all we're going to do is we're going to use the proportion of the similarities to get the answer that we're looking for. Okay, please find me the scale factor of that first one over there. Okay, actually, you can do both. We've got 2 minutes, and teacher knows I lied. I'm just going to be late to Unum. It's fine. I'll just be late. Okay. Let's calculate for both of those. You've actually, guys, I can only give you 1 minute, and I don't even think it's that deep. It's not even that deep. Okay. Except it's about to get deep, actually, a little bit. Rulani is okay. Yeah. All right. Let's talk about this, guys. Now, the answer that I have over here is going to be squared, right? So if I take 720 for A, if I take 720 and I divide it by 45, how much do I get? What do we get, guys? How much do we get when we take 720 and we divide it by 45? Give me an answer in the chat. We get 16, correct. We get 16. But is this the scale factor? Is this the scale factor? No, it's not. Rulani, why do we say it's not the scale factor? Because what would we have to do to this number to get the actual scale factor K? Correct. It's not the squared number. Yes, Muzukanya, that's it. We still need to square root it because normally our factor for a squared number needs to be that number squared to give us the factor. So we need to take the square root of this answer, the square root of this answer, which means our scale factor is actually 4. All right. Beautiful. Thank you, teacher Nels. K squared is equal to 16, not K. Good. I feel like teacher Nels is going to teach this class one day. I'm going to take a break and she'll teach. Okay. All right. Now, we're going to do the exact same thing when it comes to the volume. Right? We're going to take the volume, 1728, divide that by 64. How much does that give me? It gives us 27. But because we know that this is the volume, the K factor is actually K cubed. Our B over here is K cubed. Oh, I put the equals on the wrong side. Right, this is K cubed. So in order to find K, we still need to take the cube root of that. So the scale factor we're actually looking for is 3. All right, it is exactly 7 o'clock on the dot. I am